It appeared as a streak in deep survey footage, a single moving point cutting through the background of fixed stars. The signal was faint but constant. Across multiple frames, its motion refused every model of known objects. At 58 kilometers per second, 3I Atlas crossed the detection threshold. Then it exceeded it. The first readings from the Near-Earth Object Survey were dismissed as noise, but cross-confirmation from the European Space Agency removed doubt. Not a satellite, not debris, not local. An object from beyond the solar system, traveling faster than any comet ever recorded. Speed became the anomaly. Precision became the implication. And the paradox formed at the edge of measurement. When motion escapes its model, what remains to define truth? The first signal of 3I Atlas appeared on a late sequence from Hawaii. At first, it was dismissed as a streak from a passing satellite. But on closer inspection, the line was steady, continuous, and mathematically precise. The object crossed multiple sensor grids with identical angular velocity. No known comet, no asteroid, no fragment ever held that kind of linear consistency. Teams at NASA flagged the data and began verification sweeps. They checked for camera drift, optical reflection, even interference from passing aircraft. Every correction left the same trace: a single luminous body moving at 58 kilometers per second. Within hours, telescopes in Chile, Spain, and Australia joined the observation network. The parallax confirmed one thing: it was not bound to the sun. The orbit was open, hyperbolic, and interstellar in origin. A visitor from beyond the solar system, approaching and departing faster than models allowed. Its spectral signature revealed simple molecules: carbon monoxide, water ice, and ionized dust. But the distribution curve was wrong. Energy output remained stable where evaporation should have accelerated. At that speed, any ordinary comet would have fractured or burned into plasma. Atlas held together, cold and consistent. The comparison was immediate. The interstellar comet Borisov had entered years before, moving at 32 kilometers per second. The object called Oumuamua, strange and tumbling, crossed at 37. 3I Atlas exceeded them both, shattering the theoretical ceiling for natural cometary velocity. For human scale, that speed equals Earth to the Moon in roughly 2 hours. In less time than a single movie, this object could traverse 250,000 miles of space. Even light itself, measured in seconds per distance, seemed less absolute when faced with such kinetic endurance. Instruments showed no variation in brightness, no tail disruption, no temperature rise, no decay in trajectory. It moved as if untouched by friction, as if resistance had no claim over it. Every image confirmed, not acceleration, but permanence. An object in perfect transit through a medium that should have slowed it down. Scientists called it an anomaly. But the data was empirical. 3I Atlas was not faster than thought. It was faster than the framework that allowed thought to measure speed. If reality moves faster than theory, who measures the world? When NASA confirmed the trajectory, the object was already beyond Mars. Telemetry streams from the Deep Space Network began arriving in intervals of seconds. Each packet carried numbers that stretched the precision of every known constant. 3I Atlas maintained a speed of 58 kilometers per second across interplanetary distance. No measurable variation, no acceleration curve. It was motion at equilibrium, kinetic energy held in balance. At that velocity, Atlas would reach the orbit of Neptune in roughly 100 days. Its flight path cut through the ecliptic at 23 degrees, entering from a vector that did not correspond to any mapped stellar route. The simulations run at Goddard Space Flight Center attempted to reverse trace its origin. The results scattered across timescales and gravitational frames, placing its likely ejection between 500 million and 1 billion years ago. It was a messenger without memory, a fragment of another system crossing ours by probability alone. Spectral data from the European Space Agency revealed composition unusual for a comet. The albedo pattern suggested an outer shell of dark silicate crust covered by compressed carbon ice. The structure density exceeded all prior measurements, denser than basalt, yet lighter than nickel iron. The core temperature remained constant despite rising solar flux. In known physics, that would mean energy equilibrium at an impossible ratio. The surface neither boiled nor fractured. It stayed stable, frozen under heat. Each new image refined the paradox. The coma was faint, symmetrical, and fixed. No plume, no variable outgassing. Even at peak approach, the tail extended only a few thousand kilometers, a fraction of expected length. Instead of a streaming arc, it resembled a quiet envelope of dust bound to the nucleus by cohesion alone. For comparison, Halley's Comet loses half a meter of surface each perihelion pass. Atlas, under double the energy load, showed no detectable erosion. Instruments tuned to magnetics returned another surprise. No measurable magnetic field. No plasma sheath. The solar wind passed around it as if through vacuum. That absence of interaction rewrote drag calculations that had stood for 60 years. For human perspective, at 58 kilometers per second, 3I Atlas could travel from Earth to the Moon in roughly 2 hours, or from New York to Tokyo in less than 4 seconds. That analogy compresses cosmic distance into human scale, but the principle holds. We have never recorded sustained motion at that rate without artificial propulsion. NASA's dynamics teams recalculated orbital mechanics using expanded constants. Every iteration collapsed at the same point: structural stability. The equations demanded material strength far beyond molecular cohesion. It was as if the nucleus resisted the common rule that speed creates heat and heat creates loss. Atlas contradicted thermodynamics not by theory, but by evidence. Over weeks, additional observatories joined. Chile, Spain, Australia, and South Africa logged readings through different atmospheric layers. Each confirmed the same vector, the same speed, the same silent persistence. No outburst, no variation, no explanation. As the data grew, scientists proposed terms to contain it: hyperbolic interstellar body, cold motion nucleus, entropy stable object. Each name was an admission that the physics no longer held a vocabulary for what they saw. Computational models attempted to include relativistic correction, but even that produced negligible difference. The numbers refused to move. Atlas moved anyway. If prediction collapses before speed, what remains to measure? Velocity is a simple concept. It is distance divided by time. But when an object like 3I Atlas travels faster than all predictive models, the simplicity dissolves. Speed becomes not a property, but a boundary between what can be known and what can only be recorded. NASA's engineers describe motion through data points: position, brightness, temperature, wavelength. Each represents a frame of certainty. But when the object's motion exceeds our calibration rate, the frame itself begins to slip. The comet does not break physics, it only outruns our method of observing physics. In every measurement, there is delay. Light from 3I Atlas takes minutes to reach the sensors. By the time we record its image, it is already millions of kilometers away from where it appears. We are always watching what has already passed. When we say it travels at 58 kilometers per second, we are measuring the ghost of its position. In this way, motion at interstellar scale is also motion through knowledge. The faster the object, the less the data can define it. Atlas forces science to confront that edge, to admit that speed may exist independent of comprehension. The paradox deepens when thermal data is added. If a comet moves faster, it should absorb more radiation, lose more mass, and heat beyond stability. 3I Atlas remained cold. It radiated less than expected, as if its surface rejected energy transfer. Cold motion, energy without heat, speed without loss. This is not poetry, it is a measured result. Physicists at the Jet Propulsion Laboratory proposed an explanation involving microfractured carbon ice behaving as a natural insulator. Others modeled a magnetic field too weak to detect, but strong enough to deflect ions. Neither model fits the data entirely. The numbers describe an object that maintains equilibrium, where entropy demands change. If matter can move faster than its own decay, what does that say about time as a function of motion? Perhaps our measurement of time is only local. Atlas moves through a different ratio, where velocity maintains stability by rewriting duration. The faster it goes, the slower its own experience of loss becomes. That would explain its endurance, but it would also mean that speed alters existence itself. In practical terms, the comet is not violating physics. It is revealing that our version of physics may not be complete. Every discovery that exceeds expectation forces the boundary to move outward. This is how science expands, not through certainty, but through contradiction. Atlas is a reminder that the universe still hides gradients of reality that cannot yet be simulated. It shows that motion can remain constant even when comprehension fails. The silence of its data is not emptiness, it is precision beyond reach. When speed defies expectation, what stays measurable? 3i Atlas is gone from our instruments now. Its signal has faded beyond the outer boundary of the solar system. Only archive photons remain, recorded light still descending through the deep space servers. Each fragment of data is a delayed echo of an event already vanished. NASA's last confirmed readings placed it moving outward past the orbit of Neptune. At its current speed, it will leave the sun's gravitational influence within a decade. From there, it will drift through interstellar silence, crossing 1 light-year every 10,000 years. No mission follows. No probe will intercept it. The object belongs to the space between stars. Scientists continue to replay the frames. Each analysis ends with the same numbers: 58 kilometers per second, stable brightness, no decay, a straight line through uncertainty. The paradox lingers in every equation. If our models cannot describe what we observe, then the object becomes a mirror for the limits of knowledge itself. Atlas does not accelerate or slow. It does not explain. It only continues, a pure fragment of momentum detached from context. Through its passage, we glimpse the truth of measurement. Every act of observation is bound by delay. Every equation assumes a frame that the universe does not honor. 3i Atlas is not faster than prediction. It is outside prediction. Somewhere beyond the heliopause, it still moves. Invisible, unmeasured, unchanged. The light that left its surface will take centuries to reach our next sensors. When it does, we will be different. Our definitions of motion will have shifted again. If motion surpasses all models, what is left but stillness? That is motion. Measurable, cold, still.